Now let's start this question. Is easy level question, but it's a little bit tricky. But if you understand the logic behind the scene, you actually it's not too hard. Now you're given a non-empty array of non-negative integer non-array. The degree of this array is defined as maximum frequency of any one of its elements. Your task is to find the smaller possible length of contiguous subarray of lengths that have the same degree as none. So if you find out the maximum frequency have more than one, so you need to comparing the smallest possible length, right? So now my solution, I just use a two hash map. First hash map using I will show you here. And the first hash map is the digit and with the frequency, and the digit with the partition. That's why here two. To mean we need to find out here last position and the first position, and then with last position subtract first position, we got the length, right? And now here we also will do the same thing here. So we just comparing which one is smaller possible length, right? So it's my solution. Now, first we start here. We have the pointer because we need to go through this array, right? Now when we go through this one, so we know the hash map doesn't have the one, right? So here we can put the frequency here is one. Now we also need to assign one to this hash map, and then we can put the first position. You can understand first position and the second position. Now, because here only have one, right? So we can both position make as one. You can do this way. So here now after we make here, we can update last position. Just keep updating. If we still encounter other one, if here if we meet here, we update here. Only update here. Don't change in the first position because we need to get the length, right? So now if here we keep updating here, so you just follow this idea to solve this question. Now here, now we here go through the second number, like 2, right? Obviously 2 is not present in the hash map, right? So we get frequency 1, and then here we do the same thing, the 2, and the position sorry, here position should be 0, and here's 1 1. Now we go to here. Okay, we know the 2 already in the hash map, so we just increase the frequency by 1. Right here we can the frequency 2 become 2 because 2 occurred 2 times. Now we need to update the last position. So now we can, here is 2, right? Now we point to next position. If 3, definitely we just occur 1 time, and 3, and the 3 and 3. Now point to 1, okay. The 1 increase and the frequency increased by 1. So here should be 2, right? Simple. Now we know the 1 already present in the second hash map. So we need to change the last position. Now 0, 1, 2, 3, 4. So here should be 4. It's 4, right? Now we know we already point to the end of the array. So we need to, okay, finish everything. Now we need to find out which one is have the maximum frequency. Now we know 1 and 2 occur 2 times, right? Now we need to follow the second requirement to find the smaller possible length of contiguous subarray of nums, right? Now here we know we just ask these 2. Now we got the 4, minus 0 plus 1, we got 5 here. And here 2 minus 1 plus 1 equal to 2. Right, so this one's smaller, right? So we just say, okay, 2, the result should be 2. Yeah. Now, just follow this way to find the solution. Now I will show you how to code it up. Now, we have 2 hashmare, right? You can say frequent map. Now we also have second map. The second map is position map. We can here's the map. It's position map. Now we also have maximum frequency, right? Let me go through this one. So it's not should be something this way because we need to keep track of the precision. Now it should be not I. Okay, O by default. Oh, it's not map. Sorry, it's free map. No, it's not. And we also need to put here is 0 plus 1. It's a map get times I greater than max frequency. Okay. We need to equal to, okay, sorry, it's not map. Our now greater, this one is greater than max frequency. Now we can copy this one and assign to here. And then we also need to do one thing. It's the partition map. Okay. Its position map contain key, right? We need to, if not contain a key, okay, we know the partition, the put, the length, I, sorry, else, okay, now which means the position already have the num digit, right? So we need to update the last position. Get, right? I now we finish this one. We go to here. We need to what happened here? No. So we need to check key. We need to go through this one. You can see now we have key, the frequency map, the key set, key. We don't need to do here. We need to frequent. The get. Okay, key. Now, if frequent equals to max, now we also here have the maximum length equal to integer. Okay. go to we got this one a partition map. Partition get it's the key, right? It should be 1 minus sorry, it's partition map get key 0 and the plus 1. Okay. Now, actually here nothing is I can do later. This means now we need to comparing, right? So we can now I think all the name you can see pass on the test case. Oh, let me submit it. Okay, you can see even though it's not pass, it's not be 100%. I think you can use the solution, and then the time complexity is b of n. The space complexity is also b of n. So thank you for watching this video.